hustle over to McDonald's. I'm having fun at McDonald's.
Tip.
All right, yeah, we're live, so
All right, sweet. Let's get this done.
yeah.
We got everybody here?
Yep.
Okay.
Before we get started, I guess are we just gonna go through the questions, or does anyone have any questions before we start going through the preparation questions?
I'm good.
Yeah, just a couple. Let me look here real quick. Oh, I can't remember what it was. The question on the percentile one. When I printed my I saw I put the percentile, for example, on 7C, it didn't print it didn't say 10, so I had to just figure that a second ago, but I think I'm okay other than that. Yeah.
What question are you talking about, Garth?
It was 6C. I don't know if you guys have this problem, but when I print out like the preparation assignment, it leaves out some of it doesn't do the A, B, C, D, and it doesn't, for example, 6C says if a student's score is in the blank percentile, mine doesn't print the 10th percentile. Do you guys have that issue?
Well, I don't print it out, so I don't have that problem.
Okay.
Yeah, no,
I
I tried to print. My computer was really weird where it printed the graphs and then whatever blue lettering it was. But then again, I got my printer from DI, so it's very, very crummy.
I had to print mine so I could read it on the plane coming out. But anyway, I think I'll be okay.
All right, I guess is that it, Garth, then? Was that the only issue?
I think that's the only one I had. Somebody had one on number 7 when we were talking about the room temperature. 1800 is the mean. I think I'm okay. I just barely got some of these done, so I'm a little behind.
We'll talk about them when we go through them then. So are we gonna go over part 1? We probably should, huh?
Yeah.
Yeah, we can.
We could if you want to.
Okay, so the number 1 says classify each of the following batting averages as either unusual or not usual. Use the Z-score to make the determination.
Of course, you had to find the mean and the standard deviation first, right?
Yeah, the mean was 0.261 and the standard deviation was 0.034. It was in the reading, and then from there, yeah, you could get the Z-score for all of them. And then in the textbook, it says if it's greater or less than negative or positive 2, then it's considered unusual. So, or, yeah.
Yep.
But, so everyone so for A, I got unusual because the Z-score was negative 2.08.
Yep.
And
I
then
got the P-score is negative 2.094, right?
the P, you said the Z or the P?
The Z, I'm sorry. The Z-score was negative 2.094. So that was not usual.
Mm-hmm.
Thought it was weird how the answer put it as on the answer sheet they used a different word. So they put unusual or not unusual,
Yeah.
which is fine.
So we're on
So it is unusual.
D are unusual, and then D is, or no, B and C are not unusual, and then D is unusual.
Mm-hmm.
Sorry.
Correct.
Exactly.
Okay, go to number 2. Find the probability that a randomly selected professional baseball player will have a batting average that is greater than 0.335. So,
Yeah. Gotta say that. I gotta say that applet was pretty cool. When I was learning math 100 years ago, we didn't have that.
Yeah.
So that's pretty cool.
yeah, it definitely helps for sure.
So I
But
came up with
as
0.015.
Yep.
Yep.
Okay, then 3, provide a brief description of a normal density curve. Describe the shape and the properties.
Pretty much it's symmetric, and I know the answer sheet says it is determined by its mean and standard deviation. I don't know what other things to talk about what a normal density curve is.
Just,
Yeah, the one-
Bell shape.
Mhm.
Then the density curve always lies on or above the horizontal axis.
That's right, yeah.
The total area under the curve equals 1.
Right.
I think that's it.
Yep. Right on.
Okay. Number 4, in the following z-score formula, z equals the x minus u over, don't know what that is. Please state what each symbol stands for. So the z tells how, what I got, the z tells how many standard deviations away from the mean or certain observation lies. Then the
X is
X equals
And the
value.
data point.
and then the x is the observed data point.
Right.
And then the u thing is the mean of the population.
I always thought that looked like an M.
Yeah, I guess it doesn't pick an M.
It does. So you with the extra squiggly.
Yeah.
Mm-hmm.
I mean, it kind of does look like a cursive M.
It just makes me remember it easier. M stands for mean. No, that's how.
Yeah, that's true.
It's a good way to put it.
Yeah.
Good idea.
All right.
And then what it's getting divided by is the standard deviation, the O with the squiggly on the top.
Squiggly. Right.
Did everyone get those then? Get that?
Yep.
Good.
Okay, and then 5, I mean, does everyone understand the 68, 95, 99.7 rule?
Yeah.
Yeah.
Okay.
Now that just holds
Yes.
true for normal, right?
What was that?
I say that just holds true for a normal distribution, right?
Yeah, only for normal.
Okay.
Yeah. All right. Move to part 2 then.
Yep. Well, we got number 6. Oh yeah, part 2. Yeah. Sorry.
Yep.
My bad.
So yeah, 6 is the mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8.
Mm-hmm.
So I mean, part A is just
Anybody
labeling.
ever taken a GRE? I didn't know what that was. Probably called it something different when I took it. I had to look it up on Google. But I got it. Verbal, quantitative, and an analytical writing, right?
Yep.
I didn't know what that was. Okay.
Yeah. So part A, I got for the M or the mean, I got 100. You just label 150.8, and then as for the standard deviation, put 8.8.
Yep.
Part
Did any of you
B
find that
is
redundant?
what proportion?
Did you find that redundant that they already gave us that and then they ask us what it is?
Yeah. Making sure we understand the
Okay.
formula. That's what it's making sure. So.
Okay. All right.
B, what proportion of the people who take the quantitative portion of the GRE will score above 160? What was everyone's answer?
0.0533.
Yeah.
Yep. And the Z score was 1.6 .6136.
Yeah.
So C, where is the 10th percentile? What would their corresponding z-score be? What was everyone's answer?
Negative 1.2816.
Yep. Okay, D, what is the quantitative GRE score for a student who scores at the 10th percentile?
Not very good. 139.5.
What'd you get, Garth?
I say that's not a very good score, but 139.5, I guess.
Yep,
Yep.
that's what I got.
Sorry, I got extra noise here at McDonald's.
All right. Okay, let's go to number 7. I think we're all doing good. So yeah, the mean speed of hydrogen at room temperature is 1800 meters a second with a standard deviation of 600 meters a second. So yeah, part A, at room temperature, the mean speed of hydrogen H2 particles is approximately normal with a population mean of 1800 meters per second and a standard deviation of 600 meters.
Yep.
Right.
Okay. B, what is the probability that a randomly selected particle has a speed over 2500 meters a second? Would everyone get?
0.1217.
Yeah, that's what I got.
Yeah, just round it to 0.0123, yeah.
Okay, C, what is the probability that a randomly selected particle has a speed that is less than 2500 meters a second?
0.8783.
Mm-hmm.
Mm-hmm. D, what is the probability that a randomly selected particle has a speed that is less than 1500 meters a second?
3085.
Yep.
Yep. Then party, this one took me a little while because I didn't feel like it was clear in the book at all what to do. But yeah, what is the probability that a randomly selected particle has a speed that is between 1500 and 2500? I got the 0.5698.
Yeah.
Yep.
That one kind of threw me a little bit too.
Like when you guys say that, like how to calculate it or what numbers they're asking for.
I just had to calculate it. Well, I wasn't sure what to do, but really, yeah, you just minus the 0.87, the 2 percentages, and you get the
Yeah.
So you just have to figure the 1500 and the 2500 and take the difference, right?
Yep.
That's what I did too.
And then for F, what is the third quartile of the speed of hydrogen at room temperature? I
That
got
one kind of threw me a little bit.
What was that?
How'd you guys figure that?
2204.
That was kind of goofy on that one.
So when you use like the what do they call like the applet, where you can just plug in the third quartile, which when you say third quartile, that's the 75th percentile. Yeah, 0.75. So if you just plug in 0.75, then it'll bring up the z-score, and then you use the z-score and work your way backwards. That makes sense.
Oh, that does make sense. Yeah.
Yeah, you solve for X because you already have the z-score. You have every variable but X. So yeah, you can solve for the
Perfect.
value. Yeah.
Thank you.
8 is the last one, and it's just determining if the PQ plots are normally distributed or not. And from the textbook, I mean, it says if it's curved or gradually curving, I mean, it's not normal. And if it's kind of on this line, then it's normal. So plot A would be, I got not normal.
Mm-hmm.
Yes, not.
Plot B, I got not normal as well.
Yep.
Right.
Plot C, normal.
That's pretty good.
Plot D as well, normal.
He looks good.
And then the last one, oh no, okay, plot E I got not normal.
Yeah.
And then the F is normal.
Yeah, F is normal.
Looks good.
All right, any other questions before I stop the broadcast?
Nope.
No.
Okay, let's move on to the quiz then.